Okay, we want to continue our work with integration by substitution. Over here I have the integral of 3t squared cosine t cubed dt. Looks like it's going to work out pretty well if I just let u be equal to t cubed, because I know I can integrate cosine of u. So if u was equal to t cubed, then I know when I differentiate t cubed, I'm going to end up with a derivative that has a power 1 less, or t squared. So this looks like it might work out pretty well real quickly. So du then is equal to, I differentiate this, 3t squared dt, and then I see that I have 3t squared dt. So 3t squared dt is du, and then u is equal to t cubed. So it looks like I can just take this substitution right here, put it in, and end up with the integral of cosine u du. Okay, pretty simple, right? Cosine u du. That antiderivative is going to be sine of u plus c, and then I'll back substitute sine of t cubed plus c so that I write my answer in terms of t, just like my problem was written in terms of t. So since u is equal to t cubed, that's my answer right there. This substitution worked out. I didn't have to do anything. I just set it up by letting u be equal to t cubed. Let's look at the next problem. Here I have x to the fourth square root x to the fifth plus 3 dx. Well, I know if I let u be equal to x to the fifth plus 3, its derivative is going to have an x to the fourth in it, and that looks like it's all set up right there. So let's try that. If I let u be equal to x to the fifth plus 3, then du is going to be equal to, I just differentiate, 5 x to the fourth plus 0 dx. Okay, so what do I have here? I have x to the fourth dx. I need 5x to the fourth dx. That's no problem. I'll take this 5 and just write it here as a coefficient, and then to make up for it, I'll multiply on the outside by its reciprocal 1/5. So I haven't changed this integral at all. Really, all I've done is multiply it by the number 1, but now it's set up so that I have my 5x to the fourth dx, which is what I need for du. All right, so let's take that, substitute it in. I end up with 1/5. The integral of, okay, 5x to the fourth dx, that's my du. And then here I have u square root, so that's u to the 1/2 power, u to the 1/2 du. Okay, that's pretty easy for us to integrate. I'm going to get 1/5. U to the 1/2 plus 1 is going to be 3/2. Now divide by that same thing, 3/2 plus c. All right, almost done here. 1/5 times, I'll multiply by the reciprocal of 3/2, which is 2/3. U, which is x to the fifth plus 3, all to the 3/2 plus c, and then I could multiply this out and get 2/15 times that plus c. In any case, that's the result that I get. All right, pretty simple. I just needed a constant factor right here to give me my du. I put that constant factor in. To make up for it, I multiplied by its reciprocal, but that's okay because constant factors can cross that integral symbol. Now, what about if I had this problem right here? X cubed square root x to the fifth plus 3 dx. So that this was an x cubed instead of what I had over here, x to the fourth. Okay, I would try that same substitution. U is equal to x to the fifth plus 3. But when I find du, it's 5x to the fourth dx. To make this work here, I'm going to need to multiply by 5x so that I get 5x to the fourth here to give me my du. Well, that's not going to do me any good because my variable factors cannot cross the integral symbol. So if I multiply here by 5x to give me 5x to the fourth, I could also multiply by 1 over x, but I can't get that 1 over x out from inside this integral symbol. It's just going to keep floating around, and I'll never be able to get this into some nice form that I can integrate. So not everything is it possible to integrate by this substitution. That doesn't mean that you shouldn't try every substitution you can think of. As you get more practice with this, you'll get better and better at it, and you'll come across the right substitutions more quickly. But in any case, there's going to be some things you run across, some integrals you run across that just can't be integrated using this method of substitution.